Just after the invention of batteries, most of them were mainly non-rechargeable type. But nowadays, can you even imagine using an electrical device without recharging at least once? Well, it is true. Rechargeable batteries permeate all nook and corner of our daily life. Starting with the small torches to the wireless devices we use, almost everything uses rechargeable batteries. So what happens in these batteries? In this video, we will start our discussion with old-age non-rechargeable batteries and move on to the cells which are using in rockets and all. Simply, batteries are devices which convert chemical energy into electrical energy. Generally, they are of two types, primary batteries and secondary batteries. Primary batteries are those that cannot be recharged again, whereas secondary batteries can be recharged. And here we use the term battery, which means one or more cells connected in series. First, let us discuss about primary batteries. Normal dry cells and mercury cells or button cells in watches are examples of primary batteries. Here, reaction occurs only once and cell becomes dead after some time and cannot be reused again. The most familiar example of primary battery is dry cell or Laclauche cell based on the inventor Georges Laclauche. The cells we normally use in TV remotes and clocks are examples of dry cells. The cell consists of a zinc container that also acts as anode, and the cathode is a carbon, that means graphite rod surrounded by powdered manganese dioxide and carbon. The space between the electrodes is filled by a moist paste of ammonium chloride, that means NH4Cl, and zinc chloride ZnCl2. The reactions at anode is Zn gives Zn2 plus 2 electrons. At cathode, MnO2 plus NH4 plus electron gives MnOH plus NH3. If you look at the reaction on cathode, you can see that manganese is reduced from the +4 oxidation state to +3 oxidation state. Here, one thing to note is that electrolytic solution itself is getting decomposed through the cathode reaction, as you can see here. And ammonia produced in the reaction forms a complex with Zn2 to form ZnNH3 So you will observe a gradual voltage drop with time in case of a dry cell. Due to this reason, dry cell will not have a constant cell potential but ranges between 1.25 to 1.5 volt. Another type of primary battery is mercury cells, which is suitable for low current devices like hearing aids, watches, etc. Here, anode is the zinc mercury amalgam and a paste of HgO and carbon as the cathode. The electrolyte is a paste of KOH and zinc oxide. Here, the cell reaction at anode is zinc amalgam ZnHg plus 2OH minus gives ZnO plus H2O plus 2 electrons, and at cathode HgO plus H2O plus 2 electrons gives Hg and 2OH minus. These two reactions combine to give the overall redox reaction, that is zinc amalgam plus HgO gives zinc oxide plus Hg. Unlike the dry cell, here the concentration of electrolyte remains constant as the hydroxide ion consumed in the anode is liberated at the cathode. Due to this reason, there is not that much of a voltage drop in the case of mercury cells, and therefore you will observe a cell potential of 1.35 volt. Now let us discuss the second type of batteries, that are secondary batteries. Car batteries and nickel-cadmium batteries in smartphones are examples of secondary batteries. These batteries are those cells that can be used again by recharging because the redox reaction occurring in the cell is reversible. First, we will discuss the lead storage battery, which is used mainly in inverters and vehicles. It consists of a lead anode and a grid of lead packed with lead dioxide as a cathode. A 38% solution of sulfuric acid is used as an electrolyte. Lead storage battery have different reactions on discharging and charging stages. During discharging, the reaction at anode is Pb plus SO4 2- gives PbSO4 plus 2 electrons, and at cathode, lead oxide combined with SO4 2- 4H plus and 2 electrons to give lead sulfate and water. If you look at the overall reactions, the electrons get cancelled out and we will get Pb plus PbO2 plus 2H2SO4 gives PbSO4 plus 2H2O. During the charging stage of the battery, the reaction gets reversed and PbSO4 will be on the anode and PbO2 will be at the cathode. Then the reaction will be as given here. Another type of secondary battery which we commonly use is nickel-cadmium battery, which are used in cordless and wireless telephones, emergency lighting and other applications. But nowadays, cheaper alternatives like lithium-ion batteries are used for wireless devices and smartphones. We will limit our discussion to the nickel-cadmium cell. We will not go into the details of reactions during the charging and discharging. The overall reaction in this cell is CD plus 2NiOH thrice gives CdO plus 2NiOH twice plus H2O. Now, another type of cell is fuel cells. These are the galvanic cells in which energy produced from the combustion of fuels like hydrogen, carbon dioxide, methane, etc. is directly converted to electrical energy. One of the most successful fuel cells uses the reaction of hydrogen with oxygen to form water. In this cell, hydrogen and oxygen are bubbled through the porous carbon electrodes into the concentrated aqueous sodium hydroxide solution. Catalysts like finely divided platinum or palladium metal are incorporated into the electrodes for increasing the rate of electrode reactions. Here, hydrogen behaves like an anode and oxygen behaves like the cathode. In anode, the hydrogen gas undergoes oxidation and it combines with the hydroxide ions from the electrolyte to form water molecules and releases 4 electrons. At cathode, oxygen combines with water and 4 electrons to form 4 hydroxide ions. The overall reaction is simply the combination of hydrogen and oxygen to form water molecule. You can say that the energy released during the combustion of hydrogen is used for converting into electrical energy. The water vapors produced during the reaction were condensed and added to the drinking water supply for the astronauts. Most of the electricity which is produced in commercial as well as individual use are from thermal plants by the combustion of fossil fuels like coal, gas, oil, etc. But this is less energy efficient and more polluting. This is the reason why hydrogen-oxygen fuel cell become more important. Fuel cells produce electricity with an efficiency of around 70% compared to the thermal plants whose efficiency is about 40%. There has been tremendous progress in the development of new electrode materials, better catalysts and electrolytes for increasing the efficiency of fuel cells. These have been used in automobiles on an experimental basis. Now, do a bit of research and find what sort of reactions happen in the cells used in electric vehicles and smartphones. Yes, the working of lithium-ion batteries. With this, I will summarize this video.
Manorama Horizon. Learning made simple.